Good day everyone and welcome to Group 20. Today's Patrick and I'll be your first presenter. So it's an honor to present our project to you guys. We are very happy and excited to be sharing what we developed with you guys. So before I dive into the technical details, let's first understand the concept of BMI and why we chose this project. So BMI, body mass index, is a value derived from an individual's weight and height. Yes, so it is widely used as a screening tool to categorize people based on whether their weight is within a healthy range. So this method, while simple, provides important insights into people's health. So it is 70 kilograms and the height is 1.75 meters tall. The BMI will be calculated as the weight over the height. That will be 70 over 1.2 square, 22.86. Yes, so that will be the answer. So to calculate one's body mass index, you just have to find the height and the weight of the person, and you divide them. And BMI categories are typically divided into: 1, we have the underweight; 2, we have the normal weight; and 3, we have the overweight; and the last is the obesity. So why did we choose this project? With a growing awareness of health and fitness, a BMI calculator is a valuable tool that anyone can use. It is a simple tool, it is very accessible and an effective tool. So our goal was to create a program that only calculates BMI but also interprets the results and provides feedback in a clear and user-friendly manner. So today we'll walk you through how this program was developed, demonstrated, and how it works. And also we'll discuss the challenges we faced while we were designing our program. And we hope this will inspire you to think about how coding can solve real-world problems. Let's get started with an explanation of the core function.
Thank you. I'm Emmanuel and I'm here to explain the functionality of the BMI calculator, focusing on how the code actually calculates BMI and categorizes it in health ranges. So let's get started. This code begins with defining the calculate BMI function. And this function takes two inputs, that's weight and height, and returns the BMI value. So the function actually uses the standard formula weight divided by height squared to calculate for the BMI and keeps the calculation reusable for various inputs. So next, the program assigns example values for weight and height. So here you can see that the weight and the height are set to 70 kilograms and 1.75 meters respectively. These values are then passed as arguments to the calculate BMI function. Now the function then calculates the BMI and stores it in the BMI variable here. So the print statement here formats the output to 2 places of decimal for better readability. So now let's run the code and see. So as you can see, for the given values, it prints what? 22.86. Now the calculated BMI is then passed to the get BMI category function. This function actually determines the BMI category using conditional statements. So if the BMI is less than 18.5, then it returns underweight. When the BMI is between 18.5 and 24.9, it returns normal weight. If it's between 25 and 29.9, it returns overweight. But if it's 30 or above, it falls in the obesity category. So finally, the program assigns the result of the get BMI category, which takes the argument of the calculated BMI to the category variable here and displays it. So as you can see, let's run the code again using the same inputs here. Let's run the code. As you can see, it prints BMI 22.86 and the category is what? Normal weight, because it falls within this range here. So this program actually demonstrates modular design by separating the calculation and categorization into reusable functions, making it easier to understand and maintain. So by using the inputs 70 kilograms for weight and 1.75 for height, the code provides meaningful outputs while showcasing the utility of functions in solving real-world problems like health monitoring. So with the BMI calculator complete, I will now hand it over to the next presenter to expand the code with advanced functionality. Thank you.
Okay, my name is Abel and I'm a member of 22. Previously, we talked about the core functions that deals with the calculation aspects and the getting the category. That means getting the BMI and the category. Now, I'm going to focus on the interact aspect, how the user interacts with the program. Now, on my screen, you see a function called main. Now, this function, first of all, print a welcome message saying welcome to BMI Calculator. Now, in a try block, it prompts the user to enter his weight and height, and you can see really well that to prompt the user, we have made sure that the question is clear enough. So you can see that it's written enter your height in kilogram and enter your weight in meters. Therefore, we are able to get the height and weight of the person, and after that we have called the functions that deal with the BMI, calculating the BMI, returning the BMI, and the one that also return the category, both of them taking different arguments. The calculate BMI takes the weight and height argument and return the BMI, whilst the get BMI category has an argument of BMI and return the category. Now we are able to print it out. We are able to print the BMI at 2 decimal places and print the category also. So when we run our code and we use a weight of 65 and a height of 1.76, we are getting a BMI of 20.98 in our terminal. Let me copy and you can see exactly what I've obtained. So using a weight of 65 and a height of 1.76, we have obtained a BMI of 20.98. Now, if you see in the same function, unlike others, we have used a try and accept error handling. So if we instead of inputting numeric values, we decide to input non-numeric values, instead of the program crashing, it's going to return an error message. So when I run this code and at the place of entering numeric values, I entered non-numeric values, I'm going to get an error message saying invalid inputs, please enter numeric values. So this error handling ensures that there's always another way of letting the user know what he's needed to input. You see, instead of the program to crash and the user will not understand what happened, the try accept ensures that is not the case. So this makes the program user friendly and robust because the code is responsive. Now, in our next discussions, we will be talking about the challenges that we face in the development phase of our program.
Thank you. No project is actually complete without challenges, and we encountered several ones whilst doing our project, and I would like to highlight all the key ones and how we addressed them. The first challenge we encountered was handling invalid inputs, and you can see from here, one of the first issues we noticed was that the program would crash whenever we entered a non-numeric value. Like for example, when you run the code and you enter ABC, which is actually a non-numeric value, it crashes, the program crashes. So we actually fixed this by adding the try except block to catch errors and provide helpful feedback. So instead of the program so if you enter letters like ABC instead of numbers, the program won't crash automatically. It will display an error message rather than crashing. Yes. So when you enter ABC and you run the program, you see it will display from here. It will display error. 108%. Yes. And the second challenge we had with our codes or with our project was be accurate BMI ranges. We saw that some of the BMI ranges values were misclassified. For example, the BMI range of 24 from here, you can see that 24, when you run the code and you put 24 inside the code, 20, let's say 24.5, you see it comes overweight, but 24.5 falls perfectly in the range. It falls perfectly in the range. So we solved this by adjusting the classification logic to actually align with the global standards. So this ensures that the BMI actually falls into the correct range. For example, when we actually started, we entered 29.9 because it falls in the global standards. So it ensures that every BMI falls into the correct range, so 29.9, and when you run it, you get the appropriate range at which you need for code. Yes, and then the third challenge we had was we had user experience, early feedback. The feedback actually indicated that it was too technical for non-technical users. Yes, so we actually helped this, or we actually enhanced this by adding clear instructions. So from here you can see from the first code we did that it wasn't actually clear for technical users. It was actually very, very unclear to non-technical users. So we actually added more friendly prompts and clear instructions and error messages. So it made the program more approachable and more understandable to use. Our approach is more enjoyable. Yes.
Thank you. Testing is a critical piece in any development process, and we made it a priority to ensure our program is reliable and accurate. We tested the program in 3 main scenarios, which is the normal case. Tested standard inputs, such as a weight of kilograms and a height of 1.7 meters. The program returned a BMI of 20.76 and correctly classified it as normal weight. To the edge cases, we used extreme inputs such as a weight of 250 kilograms and a height of 0.5 meters. BMI returned as 1000.00, categorize it as obesity. To the invalid input, tested letters, special characters. The program consistently displayed appropriate error messages without crashing. Let's run another line test. We entered the weight of 90 kilograms and the height of 1.8 meters. We executed. As you can see, the BMI is 27.78 and the classification is overweight. So the testing confirmed that the program works as intended and is ready for real world use. Thank you.
Transforming problems into solutions with code. This project showcases how programming can solve practical problems. Our BMI calculator automates the process of calculating BMI, provides instant results, and ensures a smooth user experience. BMI calculator weight monitor. Adding a graphical user interface will make our BMI calculator more user-friendly and visually appealing. Seamless connectivity for real-time health tracking. Imagine a future where our BMI calculator syncs seamlessly with wearable devices to provide instant and real-time health tracking data. Our calculator could be translated into multiple languages, allowing more users globally to benefit from it. You can see we have these countries, so we can translate our calculator into multiple languages. Envisioning a future of endless possibilities. Looking ahead, this is just the beginning. The future holds limited possibilities for improvement